Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we're going to discuss a problem. Let me give you the problem, then we will discuss the solution together. I hope you will enjoy the problem with me. So the problem goes like this. A rocket is launched from rest from an underwater base a distance of 125 meter below the surface of a body of water. It moves vertically upward with an unknown but assumed constant acceleration Let me use another color. The combined effect of its engines, the Earth's gravity, and the buoyancy and drag of the water and it reaches the surface in a time of 2.15 seconds. Then the problem says when it breaks the surface, its engines automatically shut off to make it more difficult to detect. And it continues to rise. What maximum height does it reach? Then the question says ignore any effects at the surface. This is our problem. Let me check it, then we will discuss the solution. A rocket is launched from rest from an underwater base, a distance of 125 meters below the surface of a body of water. It moves vertically upward with an unknown but assumed constant acceleration. Then in the bracket, it is said the combined effect of its engines, the Earth's gravity, and the buoyancy and drag of the water, and it reaches the surface in a time of 2.15 seconds. When it breaks the surface, its engines automatically shut off to make it more difficult to detect, and it continues to rise. What maximum height does it reach? Ignore any effects at the surface. So let us discuss the solution on the next page. So let me draw a simple diagram. Use this color. So we have, let this be the surface of water. So we have a base. Let this be here underwater base. We name it. This is underwater base. Now from this underwater base, the rocket is launched. So let me draw a rocket. So let this be rocket. So it is launched. It starts from rest here. So its velocity here is 0. And the underwater base is 125 meters from the surface of water. So it is 125 meters. Now here we have water. Right? We have water here. Then it is said it moves vertically upward with an unknown but assumed constant acceleration. So it is given that this rocket underwater moves with constant acceleration. And we know that constant acceleration will be due to 4 forces. One force due to its engines. Second, Earth's gravity will act on it. It is displacing some fluid, so buoyant force will act on it, and it's moving through fluid, so it will experience also drag force. So under the action of these 4 varieties of forces, that is engines, Earth's gravity, buoyancy, and drag force, it is said in the problem that it moves with constant acceleration. And it's also given that it reaches to the surface of water in a time of 2.15 seconds. So we know when it reaches here, let me use another color. When it reaches the surface, if this is t is equal to 0, when it leaves the base, and when it reaches the surface, then t is 2.15 seconds. So it takes 2.15 seconds to reach the surface. Then the problem says when it breaks the surface, its engines automatically shut off. So when it reaches the surface, it breaks the surface of water, its engines automatically shut off. Why so? It is said that will make the detection of this rocket difficult for the enemy. Then it continues to rise. So it continues to rise, right? So it continues to move. Right? So it continues to move in the air. So here we have air. Now we have to find the maximum height reached by this rocket, right? So let us solve this problem. Now, as with any projectile in free fall, we could analyze the motion of the rocket during the portion of its motion in the air if we knew the initial velocity of that part of the motion. As you can see, there are 2 parts of its motion. One part of the motion is through water, second part of the motion is through air. Now, we can analyze the motion of the rocket in the second part, that's in the air, if we can know the initial velocity of that portion. Now, what plan we can use to attack this problem is to analyze the underwater portion of the motion to find the velocity when the rocket reaches the surface. And then we can treat that velocity as the initial velocity of the free fall portion, right? So these parts can be done separately as we are going to do them because the acceleration changes at the surface of water. So first we take the underwater motion. So let me write for underwater motion. For underwater motion, we know the displacement is 125 meter and we know the time, which is 2.15 second, and we know the initial velocity because from the base rocket starts with rest. So we know initial velocity, V naught is 0. Acceleration is not needed, but we need to find the final velocity here, right? So we can use the equation y is equal to y naught plus half v naught plus v t. Y is equal to y naught plus half of v naught plus v times t. So we make this equation, use this equation, solving for v, that is final velocity, but we get twice y minus y naught over t, because v naught is 0. V naught is 0, this will go, then we will get y minus y naught times 2 over t is our v. So we have solved for v, twice y minus y naught over t. Let us put the numbers, and we put the numbers, it is 2. Now y minus y naught is the displacement. Here we have y naught as our initial position. If the position coordinate here is y, then y minus y naught is the displacement, which is 125 meters. It is twice 125 meter over the time, which is given 2.15 second. When we solve it, it turns out to be 116 meter per second. So the velocity attained by the rocket when it hits the surface of water is 116 meter per second upward, because it is positive, so it is upward velocity at the surface. And as always, check the calculation, check the calculation at home. Now this velocity will now become the initial velocity for the free fall portion of the upward motion. Now taking this velocity to be the initial velocity, so this we take as initial velocity v naught for the free fall motion, right? In order to find its maximum height. So let us move So for the free fall portion of the upward motion, our V naught is 116 meter per second, which we have solved for the first portion, which was final velocity in the first portion of the motion through water, right? Then we will make use of the equation using V square is equal to V naught square minus 2G Y minus Y naught, right? Solving for Y minus Y naught, we get, let me use another color, Y minus Y naught is equal to V naught square minus V square over 2G. So we solve for Y minus Y naught, that is V naught square minus V square over 2G. We know when this rocket reaches the maximum height, it will momentarily stop there. So velocity there, the final velocity for the free fall portion of the motion is 0. Initial velocity is 116 meter per second. And now for this portion, this is our Y naught, the surface of water is our Y naught initial coordinate, and the coordinate here is Y, and this Y minus Y naught is the maximum height attained by the rocket in the free fall motion. So let us solve it, right? I hope it's clear to you. So let us solve it and put the numbers. Let me use another color. Let me use this color. So my V naught is now 116 meter per second. Then there is square. My final velocity is 0, so it is 0. Then there is twice. Then there is acceleration due to gravity, 9.8 meter per second square. 116 meter per second whole square minus 0 over 2 times g, which is 9.8 meter per second square. So making the calculation, it is 687 meters. This is our answer. As always, check the calculation at home. So this rocket, this height is 687 meter. From this, the surface of water to the point where rocket momentarily stops, right? 687 meter. I hope you got the problem. I repeat, I summarize the problem. We had underwater base. Now from the underwater base, rocket is launched from initial velocity 0. The surface of water is 125 meter from the base. The rocket goes through the water, re-hits the surface, and it takes 2.15 seconds to reach the surface. And we said the acceleration is constant through the this portion of the motion. There are two portions of the motion. One portion is through the water, second is through the air. Then we calculated the final velocity for first portion using this equation. It turned out to be 116 meter per second. That velocity became the initial velocity for the second portion of the motion through air. Then we calculated the maximum height attained from the surface of water, right? That is 687 meter, which is our answer. So this is all for today. Enjoy these problems, make a notebook of it. Don't waste your time, and don't forget to like, share, and subscribe my channel. You can give comment in the comment box. Thank you. God bless you. Assalamu alaikum.